So to interconvert between the number of atoms and the mass of compound, you are going to be doing 2 unit conversions. And like we've done in class for any other multiple step unit conversions, I really strongly recommend you just do this all on one line. So let's make a plan, right? We start with the mass in grams of tetraborane or B4H10. So we are going to want to go from the mass in grams of B4H10 in this case. And then from the mass in grams, we can get to the amount in moles of B4H10. Okay, but we are asked for the number of hydrogen atoms. Okay, so this is where it gets really fun. Okay, because we're going to have to relate the amount in moles of B4H10 to the amount in moles of H atoms. And I think this is the step that a lot of people forget for this kind of question. And then finally, to get from the amount in moles of atoms to the number of atoms, we're going to use the Avogadro constant, right? So which unit conversions do we need to gather together? We need to get the molar mass of B4H10, right? So tetraborane. And then we need to get a mole ratio between the number of moles of B4H10 and the amount in moles of H atoms. So we can get that just from looking at the chemical formula, right? For every 1 mole B4H10, that contains 1 mole of hydrogen atoms, okay? And then lastly, to get between the amount of hydrogen atoms and the number of hydrogen atoms, that's an Avogadro's constant problem. So 6.0221 times 10 to the power of 23 atoms per mole. So write that out as an equivalency. 6.022 times 10 to the 23 atoms is 1 mole, okay? Now we have everything organized. The only thing we have to do is calculate the molar mass of our tetraborane. So molar mass of B4H10 is going to be 4 times boron, which hopefully I haven't obscured. It's 10 point, I think that's 811. If I've misread that, I do apologize, but we're learning the method, not just looking at what the end number is. And then 10 times 1.008 grams per mole for hydrogen. So that should come out to be, grab my calculator and I'll tell you, 4 times 10.811 plus 10 times 1.008. It would help if I could, oh no, I think I did type that incorrectly. Oh, my bad. I think it's about 53.324 grams per mole. If I got that wrong because I can't read small things because I'm ye olde professor, then whatever, right? So now we're going to follow along this flowchart. Okay, so we're going to start with the mass of B4H10, which was 80 grams. We're going to use the molar mass as a conversion factor. So if you like, write it out as an equivalency. For every 1 mole of B4H10 equals exactly 53.324 grams for the amount of sig figs I've got on my periodic table. So that 53 grams has to go on the bottom to cancel out. 53.324 grams. So if I was to press equals on my calculator right now, see the grams cancel out and I'm left with moles. I am here on my flowchart, but I can just keep going, okay? This is a great way to not accidentally like press equals, write a number down wrong and carry through an error, right? If you just keep going. So next I want to get from the amount in moles of the tetraborane to the amount of moles of H atoms. So this is why I kept the moles of B4H10 and didn't just write moles, because it needs to specify moles of what, okay? So I know that my moles of B4H10 can go on the bottom to cancel out, and I should have my 10 moles of H atoms on the top. So if I press equals right now, well, the moles of tetraborane have cancelled out, giving me my amount in moles of H atoms. And then I want to get to my number of hydrogen atoms. So I'm going to use the Avogadro number. I want atoms to cancel out. So the 6.0221 times 10 to the power of 23 H atoms goes on the bottom. Oh, sorry. No, it doesn't. This is what happens when I walk and talk. I want to have my moles on the bottom. So it's 1 mole of H atoms on the bottom, my bad, right? And then you're going to have your number of individual atoms on the top. So often I'll do that just so it's not so confusing. And then if I just draw this in real quick so you can see what is cancelling, okay? So again, this corresponds to this last arrow here in our plan. So mass in grams cancels out, moles of B4H10 cancel out, moles of hydrogen atoms cancel out, leaving us with the number of hydrogen atoms. So let's see, it should be a lot, right? So if you're trying to mentally think, did I do this right or not? You're expecting a large number, usually if you're trying to calculate the actual physical number of atoms. So 80 divided into 53.324 times 10 times 6.022 times 10 to the power of 23. This should be big. Should be about 9 times 10 to the power of 24. So 9.03458 times 10 to the power of 24 atoms. Now, what were we asked in terms of sig figs? I'd round it to 3 sig figs because we were given the 80.0 grams. That's 3 sig figs. So I would round it here. And that's what we've been asked as well. So 9.03, boom, is what I would do for that. Okay, so we may be asked to do a similar kind of calculation. Instead of starting with a mass in grams, we might be asked to convert a number of atoms into a mass in grams. And in that case, we're just going to work backwards and follow the same kind of logic, okay? But it's really useful to make it this kind of plan so you can make sure that everything is cancelling. If I didn't put the mole ratio in it like this, and I just went like, oh, it's times by 10 or divide by 10, there's a 50-50 chance you're going to get wrong, okay? So you don't want to do that. All right, so let's see if we can find one if we go from number of atoms to mass in grams. So we can go back the other way. Aha! Okay, so this time we're going from number of atoms to a mass of this camphor substance. So let's make a plan. We've got to go from number of hydrogen atoms to the amount in moles of hydrogen atoms. And then we've got to go to the amount in moles of the camphor, which is C10H16O. And then if we got the amount of moles of camphor, we're going to be able to go to the mass in grams of the camphor, C10H16O. Okay, so what equivalencies do I need for each step here? Okay, you go over there, this. Let's see if I can make this move down a second, because it is actually kind of in the way. There we go. That's a bit better. All right, so to convert between number of hydrogen atoms and the amount of moles of hydrogen atoms is the Avogadro number, 6.0221 times 10 to the power of 23 H atoms per every 1 mole of H atoms, okay? That takes a bit to write out, doesn't it? All right, and then to convert between the amount of moles of hydrogen atoms and the amount of moles of the camphor, well, for every 1 mole of camphor, it contains 16 hydrogen atoms. So 1 mole of camphor, we'll get our mole ratio, C10H16O, contains 16 moles of H atoms. So I feel like this is sort of the new bit for most of you guys. You've kind of done these calculations by themselves and these ones by themselves, and it's just that sort of middle transition going between moles of a compound and moles of a constituent element within that compound and vice versa. So then the last thing, to go from the amount in moles of the camphor and the mass in grams of camphor, we're going to need the molar mass of camphor. So I should work that out really quickly. C10H16O. So that is going to be 10 times 12.011 grams per mole for the carbon, plus 16 times 1.008 grams per mole for the hydrogen, plus 1 oxygen, 1 times 15.999 grams per mole. Add those all together, and hopefully I'll do it right. Let's see. So what have we got? 10 times 12.011 plus 16 times 1.008 plus 15.999. Hopefully I get something sensible. 152.237 grams per mole. So my equivalency here then is going to be every 1 mole of camphor, C10H16O, weighs exactly 152.237 grams. So then I can just follow this down here, okay? So let's ditch the periodic table a second because it's in the way. So the number of hydrogen atoms is a trillion, 1.0 times 10 to the power of 12 H atoms. So then at this first arrow, I'm going to use this equivalency and turn it into a unit conversion factor. So I want hydrogen atoms on the bottom. So that is the number of hydrogen atoms, 6.0221 times 10 to the power of 23 hydrogen atoms. That's going to go on the bottom and cancel out and give me number of moles of hydrogen atoms on the top. 1 mole of hydrogen atoms. If I press equals right now, the number of hydrogen atoms cancel out, giving me the amount in moles, but we're going to keep going because we want to get to the amount in moles of camphor. So every 1 mole of camphor contains 16 moles of hydrogen atoms. So my moles of hydrogen atoms will cancel out. And then my last step is to go from moles of camphor to the mass in grams of camphor, which is going to be the molar mass of camphor, which is 152.237 grams for every 1 mole of camphor. Okay, so let's just make sure everything is cancelling nicely. So my number of hydrogen atoms cancels. My moles of hydrogen atoms cancels. And my moles of camphor also cancel, giving me a mass in grams, and that's what I was asked for, right? So let's be really careful, parentheses. So open parentheses, 1.0 times 10 to the power of 12, close parentheses, divided by, open parentheses, 6.0221 times 10 to the power of 23. You have to play with your calculator and see how it likes you to enter this stuff, times 1 divided by 16, times 152.237 gives me, hopefully it sounds sensible, 1.57998248 times 10 to the power of minus 11 grams. So not very much. How many sig figs should I do this to? Well, this is only 2 sig figs, so I would round like this, 1.6 times 10 to the power of minus 11. So hopefully that helps you out. It's really good for this because it's a multi-step conversion to make that plan and find the equivalency. Each arrow going from one unit to another will require an equivalency.